Today I'd like to talk a little bit about work design and then a little more about work measurement. Um, we'll talk a little bit about some basic concepts and trade-offs in different Today we'll talk a little bit about work design and work measurement. I'll say a few things about some general concepts and issues in work design, particularly the issue of specialist versus generalist. It's a decision that has to be made at the beginning of the design of the facility and the nature of the workstations. Then I'll talk about some different techniques for analyzing work and timing work and trying to estimate how long the task is going to take. And there's a lot of different techniques and tools out there. I'll talk about, start out talking about method analysis and motion study. Actually measuring work or observing work, this is a common task for interns, so if you specialize in operations, this might be something you're doing summer sometime. And I'll wrap up talking about the importance of the learning curve phenomena. Basically the fact that as people do a repetitive task over and over again, they get better and better at it, and it takes them less time to do it in the future, and we can actually do a reasonable job predicting how long that will take them to do the task in the future. So the text talks quite a bit about some of the general principles of work design. I just wanted to hit on one issue here before moving on and talking about some of the techniques and tools for designing and measuring work. And the issue I wanted to talk about was a specialist versus generalist, because this is really a big issue in deciding what sort of facility you're trying to set up and what sort of business you want to be in. I mean, this is what companies want, right? This is an ideal employee from a company standpoint, somebody who don't pay very much but who's extremely capable and can do lots of different things. And generally that's not someone you're going to be able to hire. The typical choice a company is faced with is they're either going to get a generalist, a high wage skilled generalist. An example of this would be like a skilled machinist who can work different types of machines and can set up the machine and do different types of operation on each machine. Those folks are fairly pricey. At the other extreme is the low-wage, unskilled person who can be quickly trained as a specialist. So the extreme here would be an assembly line worker, someone who has a very narrowly defined job that just takes maybe a minute or 2 minutes, and they do the same thing 400, 500 times a day. And so it doesn't take them very long to learn their particular job. And again, this applies to manufacturing and the service industry. Service industry, of course, fast food industry is built upon this whole concept. You can bring in someone with very little skill and have them quickly trained in a very narrow task. And that, of course, helps keep the price of food down in fast food restaurants. Generally, what happens in an operation, if it starts out a fairly low production volume, more like a job shop, high product variety, low production volume. As production volume increases, the nature of the business changes from being a job shop to more of a flow shop, and the generalists are replaced with specialists. So that's sort of a broad, what happens broadly speaking in the sweep of history in certain industries. As the industries become higher volume, their workers become more specialized. Also within a particular company, that can happen over time. As a company decides to focus on a few particular products at the expense of others, and they change the nature of their workforce from generalists to specialists. Now, unskilled specialist labor does come with some problems. There can be motivational issues in terms of absenteeism, quality, hostility, and so forth. Might actually have some sabotage of the product if you have motivational issues, and also causes a problem in the design of the product because you've got a disconnect between the people who are actually thinking about what the product should be and the people who are actually putting the product together, and that can make it difficult for there to be meaningful process and product improvements. But since this is sort of the trend in a lot of industries and business in general is to move as the industry matures from generalists to specialists, People have sought ways to try and counteract these negative aspects of specialist labor, since of course the benefit of specialist labor is that it's cheaper and tends to be more efficient. So there's been some solutions developed to try and counteract this. Job enlargement, basically giving a worker greater responsibility. Instead of just having them do a 1-minute task, give them 5 to 10 minutes worth of duties. Job rotation. Workers switch jobs every so many hours or so many times during the day. Or job enrichment, giving workers more responsibility and more control. And the idea here is that you're making the job more interesting for the person, so as they gain greater skill and experience in their job, you can expand the nature of their job one way or another, and that will help engage their interest. And it's also, I should note, that in lean manufacturing, some of these approaches have other benefits as well. Job rotation gives you flexibility. If the worker is trained not just in one special type of task, but can do multiple types of tasks, that's not just maybe more interesting for the worker, but that's also greater benefit for the company, because as the product mix changes, the company can move individual workers from one task to another task, one area to another area, to match the changing demand and the impact of that changing demand on changing needs for different production processes, and that gives the company greater flexibility in satisfying customer demand. So these are not all just about making the worker happier. Some of them have definite advantages for the company as well. If you can take someone who was originally not particularly skilled, specialist labor, and give them greater training as they're there longer and increase their capabilities, that increases the company's flexibility and henceforth profitability. Okay, well, I'd like now to look at some common tools used to analyze a job and try and improve the way the job is done, and also trying to measure the job. A couple of common tools here are methods analysis and motion study, and these are tools used to, again, take a look at how a process is being done currently and try and see if there's some ways to improve that process. A methods analysis I like to think of as being fairly big picture. Okay? The most common tool we're going to use here is a process flowchart or process flow diagram. We're going to look at all the operations that are being done by the worker or workers, and what we're trying to do is eliminate non-value added or unimportant operations. Trying to get rid of redundancy, cut out unnecessary transportation, unnecessary storage, and so forth, and maybe even shorten the total length of time necessary to do the job. A motion study is a little different. This is taking a more of a very small picture, micro level approach. Instead of looking at a bunch of tasks and trying to see which operations are redundant and which can be eliminated and which can be improved upon, that's what methods analysis does. Instead of doing that, what motion study is doing is looking at a single task, maybe even a single part of that task, and trying to see if there's some way that the motions of the individual doing that task can be arranged more efficiently. Basically, you're breaking motions down or movement down into very, very small parts. These small parts are called thirbligs. That's actually somebody's name spelled backward, but that's what we actually call these movement elements, thirbligs. And then there's some rules that people have determined for how these thirbligs should fit together if you want to maximize worker efficiency. So let's take a look at a methods analysis example quickly. This is a real simple example. Suppose there's a new enterprise system or computer system being put in place at the university, and that is going to speed up the availability of a faculty member to get a student's transcript. So here's the old process here before the new system is put into place, using standard symbols. Okay, standard graphical symbols for the representation of the process. So the overall process that we're interested in is the process of a faculty member getting a transcript of a student. So what's the traditional process? Well, you have the faculty member requesting a transcript from the administrative assistant, the there stands for administrative assistant, or department manager would be another name for the same person. Staff person who manages student information. And the circle here represents an activity by a worker, and the worker here would be the faculty member making the request. Well, that request goes into the in basket, which is a type of inventory or storage area of the administrative assistant. And the way that inventory or storage is represented in these methods analysis diagrams is by an upside down triangle. It sits there for a while, then the administrative assistant pulls that information and prints out the transcript. Again, because the administrative assistant is doing something, that is an operation and represented as a circle, and puts that transcript in the faculty's mail box or in basket. Again, inventory, so it's an upside down triangle. Faculty member then walks down from their office to the departmental office and retrieves the transcript, and the little arrow here, the big arrow, represents transportation. And finally, the operation, the faculty member reads the transcript. So if a faculty member wants to get a transcript of a student, in pre-computer days, this is what has to happen. You have to make the request, wait for it. Administrative assistant gets the information, gives it to the faculty. Faculty then comes and retrieves it and reads the transcript. Pretty lengthy process for something as simple as getting a student's transcript. Well, if you have a new enterprise system where the faculty member can access that information directly, you can cut out a lot of these steps. And one thing you try and do in methods analysis is cut out inventory storage that is unnecessary, and also cut out unnecessary transportation, and also cut out activities which may not be necessary, may seem not to be necessary, if you can get the work right, or get the information right to the person involved, or get the material right to the person involved, which is here the person involved is the faculty member who's trying to make a decision and get information about the student. So if we cut out all these steps, what happens now is we have a two-step process. The faculty member logs on to the web, or Western's web, and pulls up the transcript and reads the transcript. All right? So the process has been simplified quite a bit. We've cut out some non-value-added activity. The administrative assistant has more important things to do than to print transcripts up for faculty members. And also we've shortened the entire length of time necessary for this activity to happen. So that would be an example, a very simple example of methods analysis. Sort of big picture, you're looking at all these different tasks, multiple people involved, required to complete this operation. And you're trying to simplify it by cutting out the non-value-added storage, movement activities, and also people who really don't need to be involved to accomplish the objective of the activity. Now, motion study is a little different. This is much more micro level. There's a whole series, a whole book's worth of motion study principles that are printed up, and I just reproduced a few of them there. So industrial engineers generally are the people who study these things in detail, and so they learn things such as motions made by the hand should be done symmetrically. So if you want someone to move their hands quickly, and they have to move both of their hands, they should be moving both of their hands in the same direction at the same time if you want them to be able to do it as quickly as possible. If they have to move their hands in a staggered fashion, okay, as opposed to moving their hands symmetrically, that's going to take longer. Okay? And that's going to cost a very small fraction amount of time, but if they do that multiple times a day, well, that time adds up. And other common sense things like all materials and tools should be located in the normal working area. You don't want people to have to go fetching tools across the shop floor. You don't want people to have to hold tools. You want everything to be in a fixture. Again, a lot of common sense rules when you think about it that you apply to a job to try and see if you can cut out a fraction of the time necessary to do the job. The motions are broken down into very small parts, which are called therbligs, or elemental motions. These motions take a fraction of a second, and we're looking at things such as search for a part, select a part, reach a part for a part, grasp it, hold it, and so forth. And again, you're trying to see what are all the motions that are being used, which ones are necessary, and you're trying to cut out the unnecessary ones and simplify the job.